Okay, so 5.4 now goes on to the quadratic formula. I'm going to break this section in two parts. First part deals with discriminant. How does the discriminant tell you how many and what type of solutions you will find? And number two, how do you solve the solutions using the quadratic formula? So again, this section is another way of finding the value of x for a quadratic equation. I like the quadratic formula because it's a surefire way to get it, to get the solutions. Factoring is nice. I'm pretty fast at factoring, but not every equation can be factored. Every equation, if you put it in standard form, can be used with the quadratic equation, or every quadratic equation can be used with the quadratic formula. So the discriminant first. Okay. The discriminant is a value that's on tell us information about our solutions. Okay, so it's a little small formula that we're going to be able to calculate, and we're going to be able to know a little bit about what the solutions are going to be or what type of solutions they are. Okay. Equation has to be in standard form, so make sure you move things around. Ax squared plus bx plus c equals 0. Okay. Once it's in standard form, you're picking out your a, your b, and your c, and the formula for discriminant is b squared minus 4ac. Once you have that, this is the important part. It's telling us how many and what type of solutions it is. If the discriminant is positive, there are two real solutions. If the discriminant is negative, there's two imaginary. If the discriminant is 0, there's one real solution. We care about positive, negative, or if it equals 0. No matter if it's positive 1 or positive 1 million, all we're getting from this is how many and what type of solutions it is. So positive, negative, and 0 is all we really care about. Look at an example, 3x squared minus 9x plus 5. I'm just going to take the equation. It's in standard form. A equals 3, b equals negative 9, c equals 5. Watch your positive negatives. Okay? Negative 9 squared minus 4 times 3 times 5. And doing this, negative 9 squared is 81. Minus 4 times 3 is 12, times 5 we get 60. And we get equals 21. Since it's positive value, again, positive 1 million, no difference. Positive, positive, so positive 21 means we have two real solutions. All right? So again, watch your signs, especially when you're squaring that negative. When you have negatives over here, watch your multiplying. Negative 2x squared plus 2x minus 1 equals 5x plus 2. Okay, so the first thing I need to do is move some things around. I'm going to bring the 5x over and bring my 2 over. So I'm subtracting 5x, I'm subtracting 2. That's how I cancel those out, and we end up with negative 2x squared minus 3x minus 3 equals 0. Okay, so there's the equation now we're going to be dealing with. Picking out my A, my B, and my C, a lot of negatives, so again, be careful. We have negative 3 squared, 4 times negative 2 times negative 3. Okay, checking my signs, okay. Doing the multiplying now. 9 minus, we have negative 8. We get positive 24. So we have 9 minus 24 gives us negative 15. Now again, positive, positive, negative, negative, the size, the amount of value it is, we care about positive, negative, and 0. Since it's negative, we're going to have two imaginary solutions. I'm just abbreviating a little bit there for that. Okay, two parts to this problem. Okay, you're going to have to find me the discriminant and then tell me how many and what type of solutions there are. Okay, so that's the first part of 5.4, just find the discriminant. I like doing this first because the discriminant is actually part of the quadratic formula. The formula can get a little nasty, so just practicing this first and doing this calculation might make things a little easier. Before you go to the next video, you might want to freshen up on factor trees and how to simplify radicals.